Nice. Today topic is very famous topic, that is everybody is observing the keyboard interfacing with 8086 using 8255 PPI. In applications, the keyboard is very important to operate any digital electronic device. So how this keyboard is interfacing with a computer, latest computer 8086, let us see. Generally, the number of keyboards can be used for any operation, that is from 0 1 2 3 4 5 6 7 8 9 A B C D E F. So it is called as a 4 by 4 rows are there and 4 columns are there. So all keys are having a size of a 4 by 4 matrix. So when the key is pressed, the particular button will be operate in the interface 8255 PPI. Now how these key switches are different types. There is a different key switches are available. In that one, the first one is the mechanical key switches. In these mechanical key switches, there is a two metal plates are used, that is for the key press operation. These two metal plates are made with a specific material called as a phosphorus branch, and one spring is used for moving the upper portion of a upper metal piece of a key switch, so that number of key switch can be used and the debouncing can be happened. Nothing but bouncing can be avoided. So this is the simple mechanical switches. So generally a mechanical switch can be used for 1 million keystrokes, whereas the second one, capacitor key switches. Generally these capacitor key switches are we are observed for all applications what you are using everyday day-to-day life. When you are operating the keyboard of a computer, keyboard of a mobile, remote keys of a TV, and so on. So these capacitive key switches are operating with the two plates, that is one is moving, other one is fixed. When the key press is there, the mobile plate is moving, that we can observe in the animation for better understanding. So this mobile upper plate is makes the change in the capacitance because of electric field created between the two ionized plates. So like this the key press will operation will be takes place in the capacitive key switches. And one more thing is there is a third Hall effect key switches. There is a magnetic field effect will be used to identify the key motion in the key switches. See, you can observe that now there is a magnetic field is created as the voltage is applied. That magnetic field will change as the key press and unkey pressed position. So a reference current is passed through the semiconductor crystal between, so that will create a magnetic field. This magnetic field is used for the deflection. So this is the one more type of a key switches. Depending upon the application, the all affected key switch is also used for the particular key fast operation, per particular some heavy load on the key buttons when the particular applications are used. Whereas generally 90% applications the capacitive key switches are preferred. Now let us see the entire operation of a keyboard interfacing, how the keyboard is working when we are using the any key presses in between 0 to 9 and A to F. So this is the simple circuit diagram which has a already we discussed, which has a 4 rows and 4 columns. See there 4 rows are connected the port A of A255 A0 to A3, whereas columns, let us see the columns. So this is the columns. These columns are connected to the port B 0 to port B 3. So 4 rows and 4 columns are connected. So it is a 4 by 4 size. Now the remaining connections of a port B, that is port B7 to port B4, is directly connected to the all row points of a 8255 PPI. So this is the entire connections of a key switches in 4 by 4 matrix size. Now we can provide the input supply initially, that is 5 volts for all rows. See there, all 4 rows to the 5 volts, all 4 columns. This is, see there, all 4 columns to the 5 volts. Nothing but all key switches positions are, what is that, high logic 5 volts. All are 1 initially. So that you can observe that there is a all ones when the 5 volts are connected initially. Now how you can identify the key press when the user is used the any keyword on a keyboard? Now let us see. The operation, entire operation is understood by 3 steps or 3 stages. One is called as a detect, next one is called as a debounce, other one is called as a encode. Let us see the operation. Now in this operation, the first one is detect. What the detect? So we can detect the key press by using one simple procedure. We will send all zeros to the any row of our 8255 keyboard interface. Nothing but if you send all zeros, if there is no any key press, what is the initial logic values? All high, initial logic high, nothing but all ones. If there is no any key press, it will remains all ones. So like this we can identify whether the key press or unkey press. So that is the detection of a first stage. Now next one is debounce. As we seen that the mechanical switch or any capacitive switches or all effective switches, the number of key operations, when the key is pressed, it can release and again it can be pressed. So there is some bouncing problem. So for this one we have to create a debouncing. So to nullify the bouncing problem, to stabilize the key press. So for this reason we can apply 10 milliseconds delay by the software code, so that this 10 milliseconds can applied to the all ports again PB0 to PB3. See there, PB0 to PB3. We are continuously reading for any input become 0. If there is no input is 0, all ones, nothing but there is no key press. If it is 0, there is a proper contact is stabilized. So there is a no bouncing problem. So it is debounced. So the debounce is obtained in the step number 4. What is the next step, last step? That is encode. In the encode process, we correctly identify particular key what it is pressed. So that is the last step. That is third step of a 3 stages. Now let us see what is this encode. What this encode, just now we discuss particular key what it is pressed, that can be identified by using the encode process. What is the process? It is a very simple process. We will send all zeros from PA0 to PA4, all rows. Observe that all rows we send a zeros. If any key is pressed, suppose one key is pressed, so this one key connections either in the column or in the row, that will become zeros. So the particular one key pressed is identified. So this is called as a debouncing. If there is no key press is, then there is no key press is there, then what happened now? All become very simple. That is previous stage, that is called as a all ones. If any key press is found, that will become a 1 0. So there is a entire operation by using these 3 steps. Let us see one example. What is the example now? Just you can find control word to identify the key press 6. This is our key press 6. When the key press is happened here, what is our identification? Let us see the what happened to the rows. Let us see the what happened to the column. So if you can able to identify the row and the column of that particular key press, what happen? That will become 1 become 0 and this column 1 become 0. So how it is, let us see. See there, before it is for connected the logic high. Now we want to identify the key press is 6. Now when the key press is 6 is happen, so this is the row. So this is the row is connected to what? PB6. So 1 become PB6, 1 become 0. See there, let us see that 1 become 0. Same similar manner, column. Key 6 is pressed na? When it is key 6 is pressed, row is become PB6 0 and the column according to that bit of a PB1 is become 0. So what is enter control word? 1011 1101. This is the one best example to write down the what key press is identified. So this is called as a entire operation for the key press, any keyword that can be calculated. See that this is the best example. One example like that you can do all examples, and also you can write down the entire key press operations and their control words. So this is the entire operation of a keyboard interfacing with 8086 using 8255. It is a very famous application. Everybody is using the keyboard operation so that it could be better understanding by only simple 6 steps. Thank you all.